Let us look at the heating effect of electric current. When current flows through a metallic conductor, the free electrons in the metal start moving from the end which is at the lower potential. These moving free electrons collide with the atoms of the metal. At each collision, a part of kinetic energy of electron converts into heat, and slowly the temperature of the conductor begins to rise. Thus, the production of heat energy in a conductor by the electric current flowing through it is called the heating effect of the current. Let us study about Joule's law. Let V be the potential difference applied between two terminals of a conductor of resistance R. Then, by using Ohm's law, I is equal to V upon R. If the current I is passed through a conductor for time t, then Q is equal to IT. Potential difference is the work done during flow of charge Q is given by work is equal to potential difference into charge. W is equal to VQ. Put V is equal to IR and Q is equal to IT. W is equal to IR into IT. W is equal to I square RT is equal to VIT. When current flows through a conductor, the work done I square RT is converted into heat. W is equal to I square RT joule. Usually we express heat energy into calorie. The relation between joule and calorie is 4.18 joule is equal to 1 calorie. Hence, heat produced in a conductor in terms of calories is given by H is equal to I square RT upon 4.18 calories. Joule's law can be stated as the quantity of heat generated H in a conductor of resistance R when a current I flows through it for a time t is directly proportional to 1. The square of the current, 2. The resistance of the conductor, and 3. The time for which the current flows. Using Ohm's law, we can write H is equal to I square RT upon 4.18 calories is equal to V square T upon 4.18 R calories is equal to VIT upon 4.18 calories. Let us look at the applications of heating effect of electric current. In an electric circuit, the unavoidable heating can increase the temperature of the components and also alter their properties. However, heating effect of electric current has many useful applications. The most common examples are electric iron, electric toaster, electric oven, electric kettle, and electric heater. An electric bulb. An electric bulb consists of a filament. This filament becomes hot and emits light. It is made up of a metal with high melting point such as tungsten, melting point 3380 degrees Celsius. The bulbs are usually filled with chemically inactive nitrogen and argon gases which prevents their oxidation to prolong the life of a filament. An electric iron. An electric iron consists of a coil of high resistance covered by mica sheets and kept inside a heavy metal block. When electric current passes through the coil, it gets heated and can be used for ironing clothes. The mica sheet is a bad conductor of electricity and good conductor of heat. It prevents the current from entering into the metal and thus protecting the user from getting an electric shock. An important application of heating effect is the fuse used in electric circuits. It protects circuits and appliances by stopping the flow of any excess electric current. The fuse is placed in series with the device. It consists of a piece of wire made of an alloy of low melting point, for example, lead and tin. If a current larger than the specified value flows through the circuit, the temperature of the fuse wire increases. This melts the fuse wire and breaks the circuit. The fuse wire is usually enclosed in a cartridge of porcelain or similar material with metal ends. The fuses used for domestic purposes are stated as 1A, 2A, 3A, 5A, 10A, etc. In industry, soldering, welding, cutting, drilling, and working of electric furnaces are based on heating effect of electric current. In surgery, a fine heated platinum wire is used for cutting tissues much more efficiently than a knife. Let us move to the next topic, electric power. Power is the rate of doing work. Similarly, electrical power is the electrical work done per unit time. Electrical work done per unit time. Electric power is also defined as the rate at which electrical energy is consumed. The SI unit of electric power is watt. 1 watt power. If 1 joule of work is done per second, then the electric power is 1 watt. 1 watt is equal to 1 joule upon 1 second. Kilowatt is the unit which is used for commercial purpose, and 1 kilowatt is equal to 1000 watt. Formula for calculating electric power. Power is equal to work upon time. P is equal to W upon T, but W is equal to VIT joules. Therefore, P is equal to VIT upon T. Therefore, P is equal to VI. Thus we get electric power is equal to voltage into current. Using Ohm's law, we can get P is equal to VI is equal to I square R is equal to V square upon R. The commercial unit of electric energy is kilowatt hour, commonly known as unit. Kilowatt hour is equal to 1000 watt into 3600 second is equal to 3.6 into 10 raised to 6 watt second. Therefore, 1 kilowatt hour is equal to 3.6 into 10 raised to 6 joule.